Welcome to the deepest nature of space and time. Tonight, we explore a concept that feels almost impossible to grasp, an idea that challenges our very place in the universe. We will drift into the question of the center and discover the beautiful, humbling reason why the universe has none at all. Before we begin, I'd love to know where you are right now as you contemplate the infinite. Where in the world are you listening from? What does the night sky look like outside your window? Let me know in the comments below. A tiny point of light in our shared experience. And now, wherever you are, find a comfortable position. Let the day's concerns soften and fade away. Take a slow, deep breath in, and as you exhale, allow your mind to release its need for a center, to expand and drift freely into the concepts ahead. To understand why the universe has no center, we must first gently unwind our earthly intuition. We are born and live on a planet that has a definite center. We learn about cities with centers and circles drawn on paper with a clear central point. Our entire experience is rooted in objects within space, each with a middle, an edge, a location. It is only natural, then, to look up at the vast expanse of the night sky and imagine that this grand universe must also have a center. We might instinctively feel that we are either at that special center or perhaps somewhere out on the periphery looking in. This feeling is a ghost of our ancient past, a geocentric whisper that lingers in our minds. But the universe is not an object within something else. It is not a planet or star or a firework expanding into a pre-existing void. It is, as far as we can understand, the totality of everything that exists, all of space, all of time, all of matter and energy. And this changes everything. To begin our drift away from the idea of a center, we must travel back, not through space, but through time, to the very beginning, to a moment that was not an explosion in space, but a rapid expansion of space itself. In the very earliest moments, our universe was in an extraordinarily hot, dense, and unimaginably small state. The notion of space as we know it did not yet exist in any recognizable form. There was no where for this state to be. It simply was. Then, in a fleeting fraction of a second, an event known as cosmic inflation is thought to have occurred. A field of energy, known as the inflaton field, caused the universe to expand exponentially, faster than the speed of light, smoothing it out and stretching it to a size vastly larger than the observable universe we can see today. This was not an explosion, hurling matter out into a pre-existing void. It was the rapid stretching of space-time itself. Imagine the surface of a balloon covered with tiny dots. As you inflate the balloon, every dot moves away from every other dot. No dot is the center of the surface. The center of the balloon is not on the surface, it is inside, in a dimension that the surface-dwelling dots cannot access or perceive. The expanding surface of the balloon is a two-dimensional analogy for our three-dimensional expanding space. The dots are galaxies, and the stretching of the rubber is the expansion of the universe. After this period of incredible inflation, the universe continued to expand and cool at a more measured pace, entering what we call the hot Big Bang phase. Energy began to condense into the first fundamental particles, quarks, leptons, and the force carriers that would govern their interactions. The universe was a searing, opaque plasma, a dense soup of particles and energy where light was trapped, constantly scattering. For hundreds of thousands of years, this was the state of the entire cosmos, a uniform, glowing fog with no structure, no galaxies, no stars. And crucially, in this dense early universe, every single location was, in a very real sense, the same as every other location. There was no special point because the entire universe was filled with the same incredibly dense, hot plasma. As expansion continued, the temperature dropped sufficiently for electrons to combine with protons, forming the first neutral hydrogen atoms. This event, known as recombination, allowed photons to travel freely for the first time. The universe became transparent. This first light, released from every point in the universe simultaneously, has been traveling ever since, stretched by the ongoing expansion of space into the faint microwave glow we detect today as the cosmic microwave background radiation. This is our most powerful piece of evidence, our deepest look back in time, and it paints a very specific and very calming picture of the early universe. A picture that shows a universe that is almost perfectly uniform with only tiny, tiny variations in temperature. These tiny fluctuations are the seeds of all future structure, galaxies and clusters of galaxies. But the overwhelming story of the cosmic microwave background is one of stunning homogeneity. From every direction we look, from every point in space, the early universe looks almost exactly the same. This profound uniformity tells us that there was no special center point to this primordial fireball. The conditions were the same everywhere. The Big Bang did not happen somewhere in particular. It happened everywhere at once. And if the beginning had no center, then how could its expansion, the stretching of space itself, possibly have one? The center is not a place we can point to. It is a moment we all share, a moment in time, not in space. A moment that is equally in our distant past and in the distant past of every galaxy in every direction, no matter how far away. A shared origin from which we all drift, connected not by a location, but by a common history, embedded in the fabric of space-time itself. This profound uniformity, this sameness that we see in the cosmic microwave background, is the gentle key that unlocks our understanding. It tells us that the universe, on its largest scales, is homogeneous. This is a carefully chosen word, meaning that every region of space, when viewed on a grand enough scale, looks essentially the same as every other region. There are no special places. The distribution of galaxies, of clusters, and of the vast empty voids between them is statistically identical no matter where you might hypothetically be standing. Wherever you are in the universe, if you look out, you will see galaxies spreading away from you in all directions. And the further out you look, the faster they will appear to be moving away from you. This leads us to a second equally important property, isotropy, meaning that the universe looks the same in every direction. From our vantage point here on Earth, the cosmos appears isotropic. The night sky, once we account for our own local movement and the plane of our galaxy, shows no preferred direction. The distant universe looks the same whether we peer north, south, east, or west. This is a powerful observation. If the universe were isotropic from every point but had a center, then an observer at that center would see isotropy, but an observer anywhere else would not. They would see a lopsided universe with more galaxies in one direction toward the center and fewer in the opposite direction. The fact that we, and by extension any observer in any galaxy, see an isotropic universe is perhaps the strongest evidence that there is no center. There is no privileged location. This concept is encapsulated in what cosmologists call the Copernican principle. It is a modest, humbling idea, a refinement of the realization that the Earth is not the center of the solar system. It states, simply, that we do not occupy a special or privileged position in the universe. We are not at the center, nor are we on the edge. We are, in a cosmic sense, typical. Our galaxy, our star, our planet, are all made of the same stuff, governed by the same physical laws as everything else we can see. The principle is a guiding assumption, but one that is overwhelmingly supported by our observations of the homogeneity and isotropy of the cosmos. Now, let us drift deeper into the implications of this expansion. We often hear that galaxies are flying away from us, and that the farther away they are, the faster they are receding. This can feel deeply unsettling, as if we are the unwanted center of some grand cosmic retreat. But this is a misinterpretation, a final, stubborn ghost of our geocentric intuition. The galaxies are not flying through space away from us. Instead, the space between us and them is itself stretching. It is the fabric of space-time that is expanding. Imagine once more that balloon, its surface representing all of space. Draw many galaxies on its surface. Now, as you inflate the balloon, every galaxy moves away from every other galaxy. An ant living on any one of those galaxies would look around and see all the other galaxies moving away from it. From the perspective of that ant, it would seem to be at the center of the expansion, but every single ant on every single galaxy would have the exact same view. Every point appears to be the center from its own perspective, precisely because there is no center on the surface. The expansion is a property of the surface itself, not of the dots upon it. This is exactly our situation. The redshift of distant galaxies, the stretching of their light towards longer, redder wavelengths, is not a Doppler shift caused by them moving through space. It is a cosmological redshift, caused by the stretching of the very wavelengths of light as they travel through the expanding space between their source and our telescopes. The light wave is literally being stretched along with the space-time it traverses. This is why more distant galaxies show a greater redshift. Their light has been traveling for a longer time and therefore has been stretched by a greater amount of cumulative expansion. This understanding transforms our view completely. We are not being abandoned in some cosmic void. We are all embedded within the same stretching fabric. A galaxy 10 billion light-years away sees us receding from it at a fantastic speed, and from its perspective, it is the stationary one at the center of its own observable universe. And it would be just as correct and just as incorrect as we are. There is no preferred frame of reference. The expansion is happening everywhere, all at once. This leads to a beautiful and mind-quieting symmetry. The center of the universe is not a location you can find on a map. It is a moment in time. The center is in the past. It is the moment of the Big Bang itself. And since the Big Bang happened everywhere simultaneously, every point in our present universe shares that same center. A center of time, not of space. We are all equally old from a cosmic perspective. We all share that same origin point, 13.8 billion years in the past. So when you look up at the night sky, you are not looking out from the center toward the edge. You are looking back in time, toward the shared origin that connects all things, an origin that is equally distant from every point in the cosmos, weaving the universe into a single connected whole with no center and no edge. A concept that feels vast and perhaps lonely, but is ultimately a testament to a deep and fundamental unity. A universe where every location is, in its own way, central to its own experience and peripheral to none. This deep and fundamental unity, where every point shares a common origin, brings us to a concept that is both mathematically elegant and philosophically soothing: the geometry of the universe itself. For the universe to have no center and no edge, its overall shape must be a very specific kind. Cosmologists describe the possible geometries of the universe using the language of curvature, and the type of curvature determines whether a center could even logically exist. There are three primary possibilities for the large-scale geometry of the cosmos, each a beautiful and self-consistent solution to the equations of general relativity. The first is a universe with positive curvature. This is analogous to the surface of a sphere, like our balloon. On the surface of a sphere, you can travel in any one direction forever and never encounter an edge. Yet, the surface is finite and bounded. If the universe had such a positive curvature, it would be finite in volume, but without any boundary. And, just like on a sphere, there is no point on the surface that is the center. The center of the sphere lies within, in a higher dimension that is not part of the surface itself. A positively curved universe would therefore be self-contained and finite, yet still possess no center within its observable fabric. The second possibility is a universe with negative curvature, shaped like a saddle or a hyperbola. This surface extends infinitely in all directions, and its geometry is open and expansive. Parallel lines would eventually diverge. In such an infinite, negatively curved universe, the concept of a center becomes meaningless. How can an infinite expanse have a middle? Every point would just be another point in an endless, warped landscape. The third possibility, and the one which all our best current measurements from the cosmic microwave background and large-scale galaxy surveys strongly support, is a universe with zero curvature. This is a flat universe. Not flat like a sheet of paper, but geometrically flat or Euclidean on the largest scales. In a flat universe, parallel lines remain parallel forever, and the angles of a triangle always add up to 180 degrees. A flat universe is most likely infinite in extent, and an infinite universe truly and definitively has no center. It cannot. Infinity has no midpoint. You can never point to a location in an infinite space and call it the center, because there is always an infinite amount of space on every side of it. Our observable universe, the spherical region from which light has had time to reach us in 13.8 billion years, is like a tiny bubble within this potentially infinite flat expanse. From our perspective within this bubble, everything appears to be moving away from us. But an observer in a galaxy at the very edge of our observable universe would themselves be at the center of their own observable universe, a bubble of the same size, filled with different galaxies, all receding from them. There is a countless infinity of these overlapping observable universes, each with its own observer feeling quite correctly that they are at the center of their own cosmic view, yet none of them occupying a privileged center of the whole. This geometric understanding dissolves the last vestiges of the need for a center. The universe isn't just without a center. Its very geometry and scale make the concept logically incoherent. It is like asking for the center of the surface of the ocean. The question itself loses meaning. We are all adrift on this vast cosmic ocean, each in our own ship, each seeing the horizon expand equally in all directions around us. The waves, the galaxies, recede from every vessel in the same way, governed by the same gentle, relentless expansion of the sea of space itself. This expansion is measured by a single crucial number, the Hubble constant. It is the rate at which the universe is expanding today, the link between a galaxy's distance and its velocity of recession. But it is vital to understand that this constant is not a speed imposed upon galaxies. It is a rate of stretching, a percentage by which the fabric of space itself grows over a given time period. This is why more distant galaxies recede faster. There is simply more expanding space between us and them. The Hubble constant is a description of a property of space at a particular cosmic time, a property that is, according to our best observations, the same everywhere. This universal rate of expansion is the final, quiet proof that the cosmos is homogeneous and isotropic, a final, gentle whisper that there is no center to be found, only a uniform, stretching reality that treats every point and every listener exactly the same. A symphony of expansion where every note is equidistant from the silent, singular moment of its creation. a moment we are all still moving gently away from, together, in the vast and centerless dark. This symphony of expansion, this uniform stretching that treats all points equally, leads us gently to a deeper layer of the mystery. If every galaxy is moving away from every other galaxy, and the universe has no center, then what, we might softly wonder, is it expanding into? The question feels natural, almost inevitable, born from our daily experience of objects needing room to grow. But the answer invites us to let go of another deeply ingrained intuition, to release the need for an external container, and to fully embrace the universe as the totality of existence. The universe is not expanding into anything. There is no pre-existing empty void outside of it waiting to be filled. The concept of outside simply does not apply. The expansion of the universe is the expansion of space itself, and space is not contained within a larger space. It is all there is. Imagine the surface of our balloon again. As it inflates, the surface area grows. But the surface is not expanding into anything that is part of the two-dimensional reality of the balloon's skin. It is simply getting larger. The "into what" question for the ant on the balloon is meaningless within its two-dimensional world. Similarly, our three-dimensional space is simply getting larger. The question of what lies beyond the universe is a question that may have no answer, not because we lack the technology to see it, but because the framework of beyond may itself be a concept that does not apply to the whole of reality. This brings us to the nature of the cosmic horizon, the limit of what we can ever hope to see. Our observable universe is a finite sphere centered on